video, we're going to look at the bisection method application question. And with this question, it's termed as the floating ball problem. So let's go to the question and let's try to analyze this problem. So the question is asking us to find, using bisection method, to find the root of equation. So let's read the question. You are working on a down the toilet company, which is the name of the company that makes float for ABC commodes. The floating ball has a specific gravity of 0.6 and has a radius of what? 5.5 centimeters. You are asked to find the depth to which the ball is submerged when floating in water. The equation that gives the depth x to which the ball is submerged under the water is given by s cubed minus 0.165 x squared plus 3.993 times 10 exponent negative 4 is equal to 0. So we are asked to use the bisection method of finding the root of equation to find the depth to which the ball is submerged under the water. Conduct 3 iterations to estimate the root of the above equation and find the absolute relative approximate error at the end. And also we should the number of significant digits at least correct to the end of each iteration. So we are using bisection method. So what this problem is asking us to do is to do bisection method. But with bisection method, one thing you need to do is that you should get a point which is the upper limit point and the lower limit point, which can also be termed as the lower bound and upper bound. So from here, we are supposed to, from the diagram provided, we are supposed to find our lower bound and the upper bound from this diagram. Let's do this. So now with the radius given to us as 5.5 centimeters, you should convert it to the standard base unit, which is meters. So you're going to get 0.055 meters. Now, from physics of this problem, the ball would submerge between 0 and 2r, where r is the radius of the ball. Now we are trying to let this ball submerge, and the distance from the submerged area to the surface of the water is x. So in this situation, when the ball is submerging, it will be between the 0 when x is equal to 0 and when s is equal to the diameter of the ball. So it's not going to actually be the diameter, but it will be between 0 and the diameter of the ball, and with diameter is 2r. So in this case, we have our radius to be 0.055 meters. So what you do now is that we just do substitution, because now we have our lower bound and upper bound. Then we do our substitution. So the lower bound is 0, x is greater than or equal to 0 and less than or equal to 2r, whereby r is 0.055 meters. So then at the end, we can assume that our lower bound will be 0 and upper bound will be what? 0.1. So with this, because we've gotten the point, we can go on and use the bisection method. The bisection method asks us to divide the point into 2, get xr, and then we find the function value of xl, xr, and xu. Then we try that we have a rule that when you multiply the function value and you get a negative, that's what you're interested, because with that, it means that the point is close to the root of equation. So let's go to item 1 with iteration 1. With iteration 1, we know the point given to us, which is 0. So we are finding xr, which is 0 plus 0.11 all over 2, and which will give us 0.055. And that means that we're going to get 3 points, which will be 0, 0.055, and 0.11. So with this, we need to find the function value of this. But how do you find the function value? We are going to substitute these points into the function given to us and then get a function value. But before then, we need to create 2 points, which will be 0 and 0.055 and 0.55 and 0.11. So for that, let's find the function value. So for the function value, as we've seen, we know that the function value of 0 will give you 3.993 times 10 is negative 4, and with this is going to give you positive, and with this is going to give you negative. How do you then verify which point to use to continue with the second iteration? For the condition given to us, when you multiply the point created, which is 0 and 0.055, and the value you get is negative, that means that the root is close to the root is within that point. That means you can continue with your second iteration. But when it is positive, you can't. So from here, when you multiply this, the function value of this and the function value of this, you're going to get positive. It's not that you are interested, right? So when you multiply the function value of this and this, you're going to get negative. That means that the root that we're looking for is within these 2 points, right? So that is the point you're going to take to do the second iteration. But they ask us to find the absolute relative approximating error. But we cannot do that since we don't have a previous approximation. So with that, we need to get two approximation value before you can do that, right? So let's go to the iteration 2. With the iteration 2, as we know, we've gotten the point in which we know that the root will be close to it. So then we find our XR. After finding our XR, we're going to get three values. And with these three values, we're going to create 2 points out of these three values. That will be this and that and this and that. Then we find the function value and check for the condition given. So when you multiply this answer by this answer, you're going to get a negative value. And when you multiply this by this, you're going to get a positive value. That means that you are not interested in the positive value, you are interested in what? The negative value. So then we are going to take these 2 points and then continue with it. So with the iteration 3, this is what you're going to take, 0.055 and 0.0825, because their function value give us negative. Then, since we've done a previous approximation, we could find the absolute approximation error, whereby it's XR new minus XR old all over XR new times 100%. That's the absolute value. So in this case, the XR new that we found was what? 0.0825 minus the previous XR we found, which is 0.055 all over 0.0825. Then we are going to find our that's absolute approximation error to be 33.38%. We move on to the third iteration. With the third iteration, we knew that we've gotten the point in which the function values give us negative. So we are going to find the XR of it. And when we find the XR of it, you're going to get 0.06875. And then we're going to create 3 points. With these 3 points, they're going to create 2 points from this 3 points, as we do always. Find the function value of it, and then try to know which function values, when you multiply, you're going to get negative. When you multiply this function value by this function value, you're going to get negative answer. That means that the root of equation is within this point. So then we go on, but this is the case that they gave us to do 3 iteration. So we are going to find the absolute error for this. And with this, the same formula holds: XR new minus XR old all over XR new. In this case, we have our XR new to be 0.06785, but our XR old will be the previous one that we solved, which is 0.0825. And this is supposed to be 0.06875. And when you do that, the error will be 20%. Thank you very much. If this video is helpful to you, kindly subscribe for more.